Okay, in this video we'll learn how to deal with logarithmic equations. Okay, and then next video and I'll talk about logarithmic inequalities. So let's start with the easy kind of equation. So compare left and right hand side of this equation. Bases are same in the logarithmic function, right? And then I don't need to worry about all the things, okay? I need to compare only inputs because bases are same in the logarithmic function. If I compare only the input value, if they are same and I get the same thing, right? So let's solve the linear equation. Subtract 3x from both sides, that will be 2x. Add 15 on both sides, that will be 18. Let's divide both sides by 2, we get number 9. So is that solution? Possibly or not, okay? Here, important thing in the logarithmic equation. In logarithmic equation, you must check the domain all the time. So the direction says solve this and check the extraneous solutions. So let's review the graph of the logarithmic function, okay? The graph of log function goes like this. It goes infinitely high, 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 and then down, down, down. So all real numbers for the range. And there is a vertical asymptote, okay? What is vertical asymptote for the parent function of a logarithmic function? X equals 0. So domain for this function is x value greater than 0. So I need to make sure this number gives us higher number than 0. So I'm going to check that, okay? I will check. Left hand side, I have input 3 times x plus 3. I'm plugging this. Is it greater than 0? Yes, it is positive number. How about right hand side? 5 times x, which is 9. Subtract 15. What do I get? That's still positive, right? So both of the cases, check, check. So yes, this will be the solution. If it is not going to be a solution, okay? Make sense? All right. Now let's look at number 2. And we will check, left hand side, right hand side bases are same. Just like number 1a, we will compare input values. If inputs are same, and we will have the same result for the logarithm, so we can solve it, okay? This is quadratic, so we will factor it out after we organize the terms. So make 0 on one side so you can factor out. Factor it out, and you will have 2 solutions. Make sure you are using both of them or one of them or none of them, okay? So we have to check with the extraneous solutions. Let me stop here for several seconds, okay? And then let's check answers. Okay, I assume you did work, and let's check answers, okay? What are the factors from this? 6 and 2, -6 for higher number. The other one must be opposite side, right? So from these 2 factors, what are the solutions? Solutions are 6 or -2. Do I take both of them as solutions or not? So I must check, okay? So let's check. If I have a 6 squared minus 12, is it greater than 0? Yes. 4 times over 6, that's greater than 0? Yes. How about -2? -2 to the second power, subtract 12. Is it greater than 0? That's less than 0, right? Okay, now let's plug 4 times -2. Is that greater than 0? No, so this is not working. So I'm not taking -2 as a solution. -2 is called the extraneous solution. Even name has solution, it's not a solution, okay? So what is my final answer? Only 6. 6 is the solution set for this logarithmic equation. Question number 1, A and B, it was easy looking because bases on the left, right, they were same. So only what we need to compare is the input values. Question number 2 has different looking because left hand side we have logarithm, right hand side we have nothing on it, right? So we have no idea how to change this to the same base. So instead of doing that, in this case, we are going to consider rewriting this logarithm to exponential function. So number 2a, log of x with the base 2 is 7. And then I'm starting writing input as output. So I'm switching input, output, and I'm keeping the same base. What's the base of this logarithm? 2. So we will keep the same base, number 2, in the exponential form. Okay? Now I need input for exponential form, that is from output from above. What's the output from above? 7. 7 will be right there. So that's it. That's how we rewrite. Fortunately, we got answer, right? So x is same as, what's the number? 128? Yeah, that's the answer. Can I plug 128 here? Yes, domain worked, right? Because it is greater than 0. So that is the solution. Next one, like this, we want to rewrite the form. So start writing with input value, and that will be the output in the new form. Input is output. What's the base? Same as the logarithm. Is that number 3? Yes, 3 to the power of output will be input. And now let's calculate. 3 to the 4th power, 3, 3, 3, 3. So 9 times 9 is 81. Subtract 1, 80. Divide by 4, 20, right? Now let's plug in and check in the domain. 4 times 20, that's positive number, plus 1 is still positive number. So 20 is good to use, okay? That's the solution. So that's the only one solution in that. Can I find this answer by graphing left-hand side, right-hand side as y1, y2 on the calculator and find order the pair of the point of intersection and read the x-coordinate, and that is same as this number, okay? But you may not see this number if you keep your window from negative 10 to 10, negative 10 to 10, right? You need to adjust the window so you can see this number as a solution set if you are using a calculator for finding solutions. Next one, C. Ln, I have a single logarithm, and the other side I have no logarithm, okay? So nothing to compare it. So I'm not doing the same way of number 1. I need to rewrite this equation. So let's use exponential form. So let's start writing this input in the parentheses. Input will be output. Logarithm will be exponential, okay? So what's the base? Number e, so I'm using number e as a base. What's the output? Above, output was 5, so that output will be input. So let's add the number, okay, on both sides. Plus 3 on both sides, that's the answer. In calculus class, we'll use exact number like that, okay? But here, let's use approximation like the direction, okay? So let's calculate on the calculator. Where is E button? Second button and division, right? Second division, and you can find E. So let's type E to the power of 5 and then plus 3. Answer is approximately equal to 151.413, right? So that is the solution set.